Alright, this is the second video for eLab 5, and in this one we're going to talk about how to set up your spreadsheet to record data for the ramp and block experiment that I described in video 1. So the first thing you're going to do is come up with 3 columns in your spreadsheet program. The first we're going to call mass, and this is probably going to be in grams. You could also make it in kilograms if you like, if you have that measurement. So mass in grams, angle in degrees, and this is actually what you're going to be collecting. And the third column is called a weight. So this is the weight of the object in terms of newtons, not in terms of grams. So what we're going to do is, this is how I'd recommend you set up your table. Trust me, you're going to want to set it up this way for a couple of different reasons that you're going to find out about later in the activity for this lab, as well as when you're collecting data and trying to plot things. So you're going to have your mass in the X column in column A, and you're going to repeat it 3 or 5 times, okay? So in this case, I'm going to take measurements 5 times, at least 5 times is what I'm giving you as a guideline. So I'm going to write down the grams 5 times, and then you're going to run the experiment 5 times. So once you're going to run the experiment, so I got 33.2, 33.2, 33.7, 33.0, 29.4, 35.3. Those are the measurements that I got when I did my experiment. So that's my angle in degrees, and then once I've finished with that particular mass, then I can increment to the next one. So let's say I add 100 grams of water, this is 100 milliliters of water, then my next measurement would be 150. Now you don't have to add 100, you can add whatever you want. Just make sure that you can add enough water or whatever objects you can into your container so that you have about 5 masses across the minimum, which is 50 grams. 50 grams is the weight of my container, and all the way up until whatever your maximum weight is. Alright, so my next one's going to be 150. So as you can see, I'm going to do the same thing, type 150 5 times, and then do my experiment 5 times, record the angles. So in the third column, weight C, which is weight in newtons, I'm going to give you guys a little bit of a tutorial on how to use spreadsheet programs. Typically, and this is the case for almost all spreadsheet programs, including OpenOffice Calculate, Apple iWork Numbers, as well as Microsoft Excel. I'm going to show you it in Excel, but it works the exact same way in other programs as well. So you're going to start with an equal sign. So this tells the spreadsheet program that you're about to enter in a formula. So once you enter in the equal sign, it knows that it's going to be a formula, and you can actually reference other cells in your spreadsheet. So we're going to take the mass in grams. So A2, so this is A, column A, and then number 2, second row. So we're going to take A2. Just remember how you calculate your weight from your mass. Your mass times your gravity constant, 9.8 is meters per second squared, is equal to your weight in newtons. So I'm going to take my mass, and I'm going to actually divide it by 1,000, because remember, newtons deals with weight in kilograms, and I've actually measured my mass in grams. So A2 divided by 1,000 is going to be equal to 0.05 kilograms. Now we're not quite done yet, because we still need to multiply by the gravity constant. So I'm going to double click on my cell and then go times 9.8. Alright, so 0.49 newtons is my weight of 50 grams in newtons. Alright, so you only have to do this once. Once you do this, you can click the bottom right corner and then drag it down. In Apple iWork, there's a yellow circle in the center that you can drag and drag down. But basically, you click the bottom right corner and drag it down, and you should get all of these to be the same. So if I drag it down a little bit more, as expected, all the 50 gram ones are going to be 0.49, and then the 150 gram ones are going to be more. So as you can see, the program has automatically determined that the next line is going to be A3, the next line is going to be A4, A5, A6, A7, and at A7 it has switched on to 150 grams. Good, so we've got this. Once you've acquired all of your data, it should look something like this. You have your mass in grams, your angle in degrees, and your weight in newtons. So I'm just going to get you guys to be exactly the same place. So I've acquired all my data, I've calculated my weights, and if you just double click, you'll get all of them. So all of my weights are now here. Next thing we need to calculate is the static friction. Now refer back to the free body diagram in the last part of the Mastering Physics assignment, and you'll notice that I've given you guys a formula for what the static friction should equal at the maximum level. It actually equals m, the mass of the object, times g, 9.8 meters per second squared, times the sine of the angle of the ramp. All right, that is your static friction. So work it out, make sure you understand where that formula comes from. This is all examinable material, so it might show up on the exams as well. So to calculate your static friction, you need to calculate your mass, which is right here. And we're going to divide it by 1,000 again to get it in kilograms, times 9.8 meters per second squared, 9.8 meters per second squared, same as the weight, and then we're going to multiply by the sine of the angle. So the angle we calculated is here. So one other thing you need to do is that all these spreadsheet programs, they typically calculate the angle in radians, which is not typically what we do in real life. We calculate our angles in degrees. So what you need to do is surround your B2, which is your angle in degrees, by radians. So just type out radians, open bracket, close bracket, and just hit enter. So what this does is it'll automatically calculate your B2 into radians. You won't have to actually do the calculation yourself. So there you go. You then also double click, it'll take it down and then calculate all your things for you. To figure out if your spreadsheet program calculates your angles in degrees or radians, just try it out in a different cell. Equal sign, sine of 30 should be 0.5 if it does it in degrees, but it seems to be doing it in radians, so we'll add a radians in there and it'll convert 30 degrees into radians, which is pi over 6. And then there we go, sine of 30 should be 0.5, which means that our spreadsheet program here works with radians instead of degrees. So once you've got this, you want to plot these two together. You want the weight in newtons on your x-axis and your static friction on your y-axis. All right, so you want to plot all of your data just to see what's happening. To get your plot, select the two columns that you'd like plotted, and then hover over to the ribbon up top, and then click on scatter. Marked scatter, and then you should get a plot that looks like that. So at this point, you can go ahead and label your x and y axis, make the plot look nice. But you can see that for 0.5 newtons, I've got a very narrow spread, pretty narrow spread, and then for the 5.5 newtons at the high weight, I've got a bit of a bigger spread here. So that's it. Get your graph to look something like that. Make sure you label your x and y axis, give it a good title, and then you can also play around with the marker styles if you like to make it look a little bit better than the default that Excel gives you. And after that, we'll be going on to the eLab activity, where you'll be doing a couple more things in Excel or your other spreadsheet program to figure out how to analyze your data best. All right, good luck.